Hello everyone, this is a Excel spreadsheet that kind of shows how you might set up some of the problems from chapter 4 if you were going to make the calculations necessary to make these short-term decisions. All right, so there are multiple ways you can set these up, but this is some idea of what it might look like and how you would make these decisions. So the first one is make versus buy. We got our direct materials. We're looking at it initially here on a per unit basis. So if we make it, we're going to have to pay $4 for direct materials per unit we make. Direct labor $6, variable overhead $3. That would be given to us. That adds up to be 13, and if we buy it, it's 14. That's assuming the 14 includes all the cost to get it to us, shipping, all that good stuff. Right there, we have the basis for making the decision because we have our costs for making it, all the variable costs, and we have our buying costs. It seems that our making it is 13, buying is 14, so we should make it. However, caution, we also have some incremental fixed costs. Some fixed costs that only will happen if we make it. These are the ones that will be different. Only spent if we make these. There's other fixed costs, but those are irrelevant. We're only worried about the ones that will happen because of fixed costs. Now, that makes it harder to see. The question is, will we save enough on the 13 versus the 14 to cover those incremental fixed costs? So at that point, maybe it's easier to break it, do it in total. So if we need 500,000 units, okay, then it's going to cost us $4 each, or $2 million, $6 each, or $3 million, and $3 each, $1.5 million. That's the direct materials, direct labor, and variable overhead. And then we add in the incremental fixed cost to get $6,710,000. If we buy 500,000 units at $14, that's going to cost us $7 million. And so you see that, yes, it's good enough to cover the incremental fixed costs of $2,210,000. We're still lower by $290,000. So we'd be better off making it. So we could do different scenarios. We could look at the different costs and see if it still makes sense. We could even do different number of units to see what if our volume is lower? Would we still save enough to justify making it or buying it if that's what is the lower? All right. So that's how you might look at or think through a make versus buy scenario. This is a product, and you would do a very similar process if you were doing it for customers. Remember, those are very similar. So we have product A and product B. We do the direct materials, direct labor, variable overhead, the variable costs, the contribution margin. Those are the clear ones every time. We've got product A, we got product B separated. We know which ones costs go to each product or for each product, and this is the total. All right. We then have the direct fixed costs and allocated fixed costs. Now, what did we say in our discussion earlier? That we really should just get rid of the allocated fixed costs because that hides what's really happening. Those allocated fixed costs are not going to go away. They're not going to be important. They are not relevant to our decision. So getting rid of them makes it clearer that product B is negative operating profit because these fixed costs are going to go away if we get rid of product B. So here it says, according to this, if we just do product A, okay, regardless of what the other allocated fixed costs are, whatever they are, our operating profit is 706, and together with both products it's 610. So we're worse off by having product B. Okay, so we would, according to this analysis, eliminate product B or as we mentioned, maybe a better strategy would be to raise the price of product B. We also need to consider that, does product B drive sales for product A? Okay? If we eliminate product B, is that not just going to eliminate that, but it's going to mean customers are less likely to buy product A? That's going to cause us problems. And then, of course, there was the possibility that maybe product B could be replaced with another product. Then we have that opportunity cost. Or we could redo it with product C, for instance, and see what the profit is for that. So that's how you might look at a product decision or customer decision. Same basic idea. Special order. Customer comes to us, 5,000 units at $28. Our regular price is $38. So our first thought is, do we have excess capacity? Do we have the room to make this? If not, we should just keep selling at $38. We should not accept this. But if we do have room to do that, we need to look at and say, okay, can we eliminate some of the risks that we mentioned in the slides? If so, our sales of 5,000 units will be $140,000. See, this is just the cost that would happen with the special order. So you can look at it and do the whole thing with the special order, whole thing without the special order, and see what's best. But I find that it's much easier just on special orders, particularly, that just look at the incremental or the differential costs. Our sales are going to be $140,000 higher. Direct materials, okay, given to us $11. It's going to be $55. Direct labor is $5.5, so it's going to be $27.5. Variable overhead. All right, that would all have to be given to us, or we would need to know that from our analysis of costs. Contribution margin is $17.5. We do have fixed costs associated with this special order. Not a lot, but a little bit, $8,200. We still come out ahead, even after covering the needed fixed costs, assuming that that's all the needed fixed costs are for this special order. So we would accept it, and we would be better off by $9,300 than if we had not accepted it. And in doing that, we'd have to say, oh, is this going to cause people to want that lower price all the time, all that kind of thing as well. And then maybe a difference illustration of how target price and cost plus pricing works. We look around, our product is sold by lots of people, lots of competition, and the price is $2.50. We would like to make 25%. That's not an unreasonable goal. And so our cost is going to be needs to be $1.88. So we're now going to have to look at our direct materials, direct labor, variable overhead, and any special fixed costs divided by the number of units and say, okay, is those four things added up going to be $1.88 or less? If so, we can probably go ahead with this. All right. If not, then we probably should look elsewhere. And then on the other side, cost plus pricing is often used for big amounts. We used a big amount here. Okay, special project. We had, again, the agreement is that we can sell it to the customer for the cost plus a percentage for profit. We add up, we have to keep track, very close track of our direct materials, direct labor, variable overhead, some agreement as to how much of our other overhead we get to include in there. That's usually part of the contract. Total cost, by definition, that we've agreed to. This is what went into the cost, $85 million. Let's say we had 15% profit, 15% of the cost is added on top, and the price the customer is going to pay $97,750. That would be what the contract is, except it wouldn't say that amount when we started, right? Because we wouldn't know what the costs are. That's what it would tell us, that it would be the cost plus that 15%. It would end up being executed at $97,750.